Hello everyone, welcome back to Chemical Engineering and Aspen channel. In our today's video, we will look at the top 3 beginner mistakes which you do once you are simulating any process or you are doing any simulations in Aspen. This video is basically applicable for both Aspen HYSYS and Aspen Plus. We will first have a look at the mistakes and then we will see how we can fix these mistakes because of the fact that without addressing these mistakes, you cannot have a sustainable or you cannot have a reliable simulation file with you. So this is very important to know that what are the common mistakes which the beginners or even the persons at the intermediate level do once they are simulating any process using Aspen. So going to the common mistakes, number one is the wrong property package selection. Second is the incomplete stream specifications. And number third is ignoring convergence issues. We will go at all these mistakes one by one to see how these mistakes happen and how you can resolve it. But before going to the video, if you have not subscribed to the channel yet, please subscribe to the channel. Click on the bell icon to get all updates related to this channel. So going to mistake one, which is the selection of the property package or wrong property method. Usually the problem is that once we are starting the Aspen or we are choosing the Aspen, we select the ideal property package or maybe wrong property package. Basically, there are two categories of thermodynamic property packages. Number one is the activity coefficient model and number two is the equation of state. For example, if it's a chemical system, mostly activity coefficient method is adopted. Or if it's a hydrocarbon system, mostly equation of state method is adopted. But if you select the opposite method, for example, if you are studying the non-ideal behavior and you select the ideal property package, what happens? Obviously, the reliability or the results will not be reliable. So most beginners leave the default ideal or wrong equation of state, which gives nonsense results because the results are not reliable. The results are always fake. For example, if you have to simulate the ethanol water distillation, obviously, you know, ethanol water forms as you drop. You come to Aspen, you simulate the process, and there is no as you drop. What does that mean? That means that there is a problem in your data, or in your simulation. Over a wide literature, we have studied that this is an azeotropic system. So it means you have to first look at your property package. For example, if you have selected the Peng-Robinson as thermodynamic property package, it will give you a wrong answer of relative volatility. It means you are in the wrong side. You are in the equation of state. But once you switch to NRTL, non-random two liquids, you can see you will get the required results or you will get the right results. So it means that you have to select the suitable right property package to proceed with your simulation. The pro tip is, the rule of thumb is that you have to always remember that for electrolytic system, you will use ELEC electrolyte NRTL. For non-ideal liquids, you will use NRTL, Uniquac, Wilson, Unifact, and up to so on. And for hydrocarbon gases system, you will use Peng-Robinson, SRK, or equation of state property package. So if you remember all these aspects regarding the property package, that which method or which system to be used when, then there are high chances that there will be no mistake here and you will proceed to your simulation quite accurately. So this is the first mistake which you should remember. Going to the second mistake, which is incomplete stream specification. Now we have studied numerous times that the degree of freedom of a stream should be equal to 0. We define degree of freedom as number of variables minus number of equations. In Aspen, we say we are not defining the equations, we are defining or we are specifying the variables. Now, what are those variables? Any two, like among temperature, pressure, and vapor fraction, we have to define any of two. Then we have to define one flow rate and then composition. Now the problem is that simulation won't run if you won't specify the required properties. For example, if you specify temperature, pressure, and only flow rate, but no composition, you won't get any result. Similarly, if you specify temperature, pressure, vapor fraction, all these three, then the simulation is not fully specified because you have specified more variables than the required one. So simulation won't run because feed stream information is either missing or overspecified. What you need to do, you need to specify the minimum information here, that is to fill at least temperature, pressure, flow rate, and composition. Now the pro tip is that if you're unsure about the pressure temperature, pick realistic operating conditions such as 25 degrees centigrade, 180 for lab scale feed. So this is another important aspect. Once we talk about a stream specification, after obviously making sure or after ensuring that the property package is rightly selected, that after specifying the right property package, you need to provide the required input specifications for any process stream and obviously for the blocks as well. Going to the mistake number 3, which is ignoring convergence issues. You don't consider the recycle loops or the reactor does not converge. You keep on increasing the number of iterations in the system. By default, the number of iterations in Aspen are 30. You specify these to 100, 150, 200, 1000. Simulation will keep on running, but your results are not achieving. There is always an error, always an warning. Why? Because of your specifications. Because you have to specify, for example, if it's a recycle loop, you have to specify the tier stream. If you do not properly specify the tier stream, your recycle loop will never converge. So the problem is that the column recycle loops or reactors don't converge. Aspen will keep on iterating or will produce results with error. How you can fix it? Obviously, you have to provide the initial guess or better initial guesses, such as reflux ratio, minimum number of stages, product purity, and so on. For example, once we simulate the shortcut distillation column, we say the reflux ratio as minus 1.3 and it automatically calculates the number of stages. But if you specify plus 1.3, Aspen will assume that it is the exact value of reflux ratio. So your initial guess should be very accurate. Similarly, in the same interface, Aspen wants that you specify the purities of top product only. And if you specify of the bottom product, obviously your answer is not be reliable. So what you need to do, you need to use design spec and sensitivity analysis, and you have to mention the tier streams in the recycle loop. So this is the third problem, or this is the third major mistake once you encounter while doing the simulation in Aspen. So the final remarks of today's video is that you should remember these three common mistakes, that the property package, the stream specifications, and the convergence issues. Next time you open Aspen, check these 3 points first. If your simulation contains errors, if your simulation file is okay, that's fine. But if you are encountering errors or difficulties, please make sure that these 3 points are checked. And obviously, if you look at these 3 points, you will get your simulation towards solution. So if you found this video useful, subscribe for more Aspen quick tutorials and drop your questions in the comment section. Till then, it's goodbye. Stay tuned for more exciting videos on your favorite channel. Thank you.